Now, here's the question for you. Can I simplify the square root? Or is this it? Can I simplify the square root? By now you should have asked me twice already if I've lost my mind. Because we cannot take the square root from a sum. No one can simplify this. This is the distance formula. Right? Let me refresh your memory. The square root of 9 plus 4 does not equal the square root of 9 plus the square root of 4. The square root of 9 plus 4 is the square root of 13. This is 3 plus 2. 3 plus 2 is 5, which is not the square root of 13. Remember, the square root of 9 plus 4 is the same with 9 plus 4 raised to 1/2. I have to perform the operation inside and then raise to the power. So this is it. Also, there is a point right in the middle that bisects, we say, the segment into two equal parts. This point is called the midpoint. And we can easily show, we don't have to, easily show that the coordinates of the midpoint are the average. By average, we mean we sum up and we divide by 2. Average, we sum up and we divide by 2. So the coordinates of the midpoint are the average of x values, coordinates, comma, the average of y values. Okay, so now let's illustrate how we determine the distance between 2 points and how we determine the midpoint of the line segment. Please give us any two ordered pairs that you want to work with. And we will determine the distance between those two, and then we will determine the coordinates of the midpoint. Any two ordered pairs you can think of. Anyone? 4 comma? -2? Very good. And? Okay. I thought you were going to say 7. Good. First, I label them. x1, y1, x2, y2, so I don't mess them up. Second step, I write the definition of the distance. So x2 minus x1, everything squared, plus y2 minus y1, everything squared. Remember, this is a sum of two squares. All this quantity has to be a positive number. Please make sure that on the next test and the final exam, you do not write the square root of -40. It's impossible. This is a positive number because it's squared. This is a positive number because it's squared, and the two quantities are added. So this will be impossible to ever get. Okay, you know my habits already. I like to write underneath. I'm writing 3, and then I'm writing 4, x2 minus x1, and then I'm writing 7, and I'm writing -2. Because I think it's easier to write and not have to copy it several times. But you do whatever you like. So 3 minus 4 is -1 squared. And it has to be a positive number. -1 squared is perfect. Plus 7 minus -2. 7 minus -2 is 9, and then 9 squared, and it has to be a positive number, is 81. So the distance is the square root of 82. What about the midpoint? I'm adding the two x values together. When I add 4 and 3, I get good, and that's the average, 7/2. When I add -2 to 7, what do I get? Very good. And I have to divide. So this is the distance between the two ordered pairs, the distance, the measure of the line segment between the 2 points that you picked. And this is the point that will bisect the segment into 2 equal parts. And these are the coordinates where it has to be plotted. Any questions? Any questions? The last item here is the equation of a circle. Do you think a circle is a function? Of course not. By the vertical line test, it's not a function. Good. So bear with me and say that this is a circle. You'll make me very happy. Of course, it's not. It mimics a circle. This point is obviously the center. It's denoted by C. And by convention, we have the x and y coordinates of that C, h comma k. So the notation for the center of a circle is C, uppercase C. H is the x coordinate, k is the y coordinate. Okay, let's say we have a point on the circle. I'm going to denote it by A. Anywhere on the circle, I'm going to say the coordinates are x comma y. It has to have an x, it has to have a y. I'm going to connect these two. And what is the measure of AC? It has a specific name for any circle, any line segment that connects the center of the circle to a point on the circumference on the circle. This must be radius. Perfect. So this is R. It is the radius. And if I write this, please tell me whether you accept or it's acceptable or not. The distance AC is the same with the radius. Okay. Now I would like you to, so I copied the radius on the right-hand side. I would like you to use the distance formula on the left-hand side. And represent, in order to represent the line segment AC. Of course, you will have to give me something squared plus something squared, because that's how we write the distance between 2 points. What will I have in the first set of parentheses? Perfect. We are going to write it as x minus h, if you don't mind. It's the same thing. Very good. Awesome. What do we have in the second set of parentheses? That's it. And because we don't really like to have a square root in the equation of a circle, this is it. But we like to eliminate the square root. We will do what to both sides? In order to eliminate the square root, I have to, that's it. So this is the equation of, oops, I didn't mean that. Don't write that, I'm going to delete it. This is the equation of a circle. It comes from which formula? The distance formula. So please remember, commit those two to memory. They're pretty similar. Okay, so we have several types of problems here, actually 3. So 3 types of problems with the equation of the circle. Here's the first type. We are given a center. This is problem 33 on page 332. We are given the center 3, 2, and the radius is 5. They want us to do 2 things. Number 1, they want us to create the equation of the circle. And number 2, they want us to graph it. So can anyone dictate the equation of the circle? Give it a shot. X minus very good squared plus, yes, very good, squared equals, which is, this is the equation of the circle with center at 3, 2 and the radius of 5. Now let's graph it. When we graph a circle, we start with the center. So please pay attention for a second. It's very simple, I think. So we start with 1, 2, 3, 1, 2. This is the center. And then I measure 4 points. I find or I plot 4 points exactly 5 units away from the center, east, west, north, south. So here's how I do it. It's not going to be perfect, of course. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm trying to create draw an as good as possible circle. So this, all points on this circle will fulfill, will verify this equation for sure. And the center is 3, 2. So this is one type. Here is a second type of problem, like 45 on the same page, 332. And this is x plus 3 squared plus y minus 2, of course, squared equals 4. Now they want us to answer this question. Is this a circle? Yes. Why? Because it resembles this. X minus a number squared or plus a number squared plus y plus or minus a number squared equals a positive number. If it looks like this, it must be a circle. Notice that there is 1 in front of this and 1 in front of this. If I change it into 2, that's not the equation of a circle. So plain with 1 and 1, x minus a number or plus a number squared, because the number can be negative, y plus or minus a number squared, nothing else, and a number on the other side. If it's 0, it's just a point that is the center. If it's negative, it's not a circle, because I can take the square root to find the radius. So this must be a positive number. Okay, so let's see if those characteristics are fulfilled. Here, yes, 1 in front, x plus or minus a number squared, no other x anywhere else, y plus or minus a number, no other y squared anywhere else, and this is a positive number. So they want us to identify the center and identify the radius. The easiest thing to start with is to find the radius, which is very good, because 2 squared is 4. Very good. So now what will be the center? And before you say anything, always remember, what does x plus 3 do as a transformation? And you will know where x is going. What does y minus 2 do as a transformation? And you will know whether y is positive or negative. The coordinates here. So what does x plus 3 do? Does it go into the negative side or the positive side from transformations? That will be x plus minus 3. X minus 3 shifts the graph to the right. X plus 3 shifts the graph to the left. So what is the x coordinate of the center? Correct. and y 2. So this is a circle. The radius is 2, and the center is at -3, 2. And yes, we can graph it if we want to. Let me just show you the last type before we stop. I know I only have 3 minutes left, so I'm going to try. Let's look at 53. This is the last type and the last type of problem for chapter 2. X squared plus y squared plus 6x plus 2y plus 6 equals 0. Same question we're asked here. Is this a circle? I have no idea. If it is a circle, then find the center and the radius. But right now, when I look at this, I'll say I have no clue. But I remember this. So if I manage to arrange this equation like this, then the answer is yes, it's a circle. But if I cannot arrange it like this, then it's not a circle. It could be something else. And this is what we studied in this chapter, towards the beginning of the chapter, and when I said this method is not for solving quadratic equations. It's for this. What method was that out of 4 methods that we used for solving quadratic equations? Which one I said, oh, no, this is what it is. This is not for this. Which one? The one that no one liked. The completing of the square. This is what it's used for. So what do I need to add to complete the square for x? X squared, 6x plus middle coefficient is, divide that by 2, square 3. This is what I need to add to both sides to change these 3 into what? What binomial squared is x squared plus 6x plus 9? Of course. Very good. Awesome. One more. Now I need to complete the square for y. But what do I need to add to both sides? The middle coefficient. The middle coefficient. 2 divided by 2. 1 squared. So now 1, 2, 3. Plus, don't forget the plus, something squared. What? What binomial squared is y squared plus 2y plus 1? Very good. So now all we have left is this 9, this 1, and I have to bring the 6. 9 plus 1 is 10, minus 6 is 4. Does this resemble this? Good. I need the center and the radius, which means, yes, it's a circle. They are asking us to identify the center. The center would be? Very good. And the radius? That's it. So these are the